Okay, so today I'm going to be talking about an experiment called synthetic polymers and plastics. And there's several goals to this to determine the properties of some common plastics that we use. And we also are going to make a polymer using some household chemicals and then test the polymer for its bounciness as well as some of its dimensions. So plastics is a type of synthetic polymer, and a polymer is just a repeating chain of a molecular unit that is connected through covalent bonds. One of the most well-known polymer, which happens to also be a plastic, is polyethylene or PE, and the molecular structure is shown right here. It has two carbon that's connected by a single bond, and then that just repeats. So then there's another unit of this carbon single bond connected here, and then that N represents how many of those repeats are present. So for example, in this chain right here, you have one unit here, another unit here, another unit here, another unit here, another unit here. So there's 5 units of these ethylene molecular group that's repeated in that polymer. Now it could go for hundreds or even thousands of molecules long. So this is just a snapshot of a segment of that polymer. Now what does the plastic look like to us? Well, it looks like these beads right here, these pretty clear, transparent beads. And in fact, in the experiment, that's what you'll be using to test the density. We have these 6 different plastics. They're called the big 6. You might see here that there's 7, but that 7th one is a number of plastics that are much smaller in its applications compared to these big 6 right here. So the big 6 is numbered from 1 to 6 to make it easier for us to recycle them when we put them in the recycling bin for the people who are doing the recycling to easily sort them. They're called PETE, or sometimes usually just shortened as PET, high density polyethylene and low density polyethylene. That's this type of plastics. Just depending on how they're packed, they can be high or low density. PVC or polyvinyl chloride, polypropylene, and then polystyrene. And you can see here the applications of all of the different types of plastics, and in the lecture portion of the class I also discuss some more detail on how each of these plastics is used. Now in the experiment itself, you'll be doing 2 things. One, in part B, you'll be estimating the relative densities of this 6 type of plastic, and then in part C, you're going to be making and testing these polymers. So to explain how to do part B, what you're doing is you're going to take these beads, they're made of different types of plastics as shown here, and you put it in a solution. Now the solution is going to have its own density, and the way you tell how the plastic compares to the solution is by noting where the position of the plastic is. So for example, here's water, and then we have 3 different objects. The yellow one sinks to the bottom, the green one is suspended in the liquid, and the red one is floating. So this one that sinks is going to be more dense than the solution. The one that is suspended is going to have the same density, and then the one that floats will have a lower or smaller density compared to the solution. So for example, let's say you collected the data and it looks something like this. So let's say you have 2 solutions, A and B, and A has a density of 1 grams per cubic centimeter, whereas B has a density of 1.5 grams per cubic centimeter. You put 2 different types of plastics. For plastic 1, you see that it's suspended in solution A, but it's floating in solution B. So just from that observation, you can tell that the density is probably very similar to solution A, maybe around 1. But then it's not much higher than that because it's floating in solution B, so its density is much lower than 1.5. So we can conclude that plastic 1 has a density of less than or equal to 1, whereas plastic 2, you observe it to sink in solution A, but float in solution B. So if it's sinking in A, that means that its density is higher than 1.0, but it's less than 1.5, so it's somewhere between 1.0 but less than 1.5. If I compare these 2 plastics to each other, I can conclude that plastic 2 is denser than plastic 1 just by this qualitative data. So you'll be doing this again with the 6 plastic, and you're going to have 3 different solutions to help you narrow down the relative densities of all the plastics. In part C, you'll see how to make a polymer from simple household chemicals, where you just have to mix them together and then heat them up a little bit, and then you'll be able to test the bounciness of the polymer that you make, which is these balls, and then you're going to also measure its dimension.